Sterling knows this, I'm also a lacrosse coach. Okay, so when I'm here and I'm talking, you guys just pay attention, because I won't write a referral, I won't do anything like that, but I will make you do a burpee, or some air squats or something like that. So just be prepared, that's all I know how to do, I don't know how to discipline you guys anyway. So just pay attention, we'll be fine. As Mrs. Maggio said, I don't know what happened to the H and the N here, but this is my name, John Maggio, and there's PE at the end of my name. Does anybody know what that means? Oh, yeah. Physical educator, not bad. That's not right, though.
Does the E stand for engineer?
Yes, it does. What do you think the P stands for, anybody? Somebody said it was physical education last class, but no.
Professional?
Professional engineer, exactly what it means, okay? Just like when a doctor has, MD at the end of his name, that's the kind of the things that they put in the back of my name. Okay, and that means I'm a professional engineer, and I had to do a whole bunch of stuff, and I'm licensed by the state of Texas to work as an engineer. Okay, so people know when I do something that I've done a whole bunch of stuff to be in a position where I can make decisions about engineering decisions. Okay, so to be an engineer, okay, I had to go to a 4-year college, as Mrs. Maggio said. University of Texas in Austin is where I went. Then when I finished that, I had to take a test, okay, called the Fundamentals of Engineering test. I had to pass that test. Then after that, I had to work for 4 years, okay, under the apprenticeship of a professional engineer. Okay, I worked for 4 years. At that time, then I had to write this big, long application to the state of Texas saying, I think I'm ready to be an engineer now. And they said, okay. And then they go, you got to take another test. So I had to take a 2-day test, okay, and pass that test. And really the people that take it, the passing rate is only about 50%. So everybody, half the people that go in there and take that test don't pass. So after I get that, then I'm a professional engineer, okay? And then every year, as long as I want to continue to be a professional engineer, I have to take like 15 hours of classes, okay, keep current but with what's going on, okay? So what kind of engineer that I am is I'm a structural engineer, which means I deal with buildings mostly, big houses and then buildings, okay? So everything that you see, sort of, the architect decides how big the rooms are and the paint colors and where you're going to put the bathroom. It's my job to make sure it stands up. But there's lots of different types of engineers. You guys know of think of any other types of engineers? Yeah.
Petroleum engineer.
A petroleum engineer, what do? Do you know?
They try to find oil.
Find oil, that's a big one, right? Electrical engineer, yeah?
Mechanical engineer.
A mechanical engineer, all right. Anything else?
A sanitation engineer.
Yeah, sanitation, that's part of the civil engineering field. You guys got 2 more, what's one?
Chemical engineer.
Chemical engineer, yeah.
Aerospace engineer.
Aerospace engineer, okay, aeronautics.
Scoot over a little so you're in the...
I'm in the frame, is that better? Yes. I don't want to get out of the frame. Okay, last time I could wander, now I got to stay in the middle. So those are all of the things, and different engineers obviously do different things. I chose structural because one time I maybe wanted to be an architect, but I like structural because I like buildings, I like to do the construction, I like kind of being out in the field and doing with this kind of stuff. That's very interesting to me, okay? So we're going to talk a little bit more about sort of structural engineering and what I do. Okay, so one of the biggest things is the materials that I need to do to build whatever we're building. See, we live in Lake Travis, there's a lot of building going on around here, right? You guys are driving down the road, you see buildings being built and constructed at the time. So what are some materials that are being used, okay, to build things? In red shirt.
Wood.
Wood. We'll put that down. Wood. Okay. What's another one?
Steel.
Steel. Good. Perfect. Blue shirt.
Sheetrock.
Huh?
Sheetrock.
Sheetrock, now, that's a covering. Now, the sheetrock kind of stands up there. That's something they put on the walls so you can paint on or put wallpaper on. Doesn't necessarily keep the building up. Sometimes a little bit does, yeah.
Concrete.
Concrete, oh, excellent. Okay. All right. Does anybody know of any other ones? Rebar, right? That kind of goes in with concrete a little bit because they'll put the rebar, the steel rebar inside the concrete.
Nails.
Nails, those are kind of like, that goes with wood mostly. Okay, we're gonna talk, that's a little bit different, so those are a little bit, we're gonna talk about the major materials, and these are the three major materials, okay, that they use to build things. What's that wall right over there?
Concrete.
It's concrete, right? You know, some of the things that you can see, there's some steel in here. What's that material up in the ceiling? That's sort of like those white things that have the triangles in it. What material is that?
Steel.
That's steel. Okay. I don't think there's too much wood in a school usually, but your house is usually. That's a door. That's not. What if you took that door away? Is the building going to stay up?
No.
Yeah, the door will stay here, so it doesn't matter. That's just a door. All right. So these are types of things that we do. And so one of the things I have to do to determine what material am I going to use, okay, when I want to design something. Okay, we don't build everything out of steel or everything out of concrete or everything out of wood, depending on what we're doing, what the application is. Okay, we have to determine what the best material, okay, that we have to use. So I'm going to break it down, and we got to determine how to do that by things we're talking about cost. Certain materials cost more than other materials. Okay, we're going to talk about workability. Okay, and what's the last one? I'm going to erase my name. Okay, is its strength. Now, you guys are pretty smart. I'm going to go through these and you're going to tell me what you think. So if I'm talking about wood, do you think it's cheap or expensive? Okay, wood. So we're gonna give wood 3 stars. Okay, when it comes to cost. What about the workability of wood? You think it's easy to work with wood as opposed to these other two?
Yeah.
Yes.
it's easier.
Yeah, it's pretty easy. We're gonna give it again. Good, 3 stars. Now, okay. What about strength of wood as compared to concrete?
Like 1 star.
2, you think?
1.
I'm gonna give it 1 star. You gotta think about concrete, and we gotta think about steel. They're coming up. So 1 star, okay? Not very strong compared to the other 2. Now what about steel? What about the cost of it? You think it's really expensive. So we're only going to give that steel 1 star for that. What about workability? How to work it? I mean, put it up, construct it.
2
1
stars.
star. Concrete's easier.
Concrete. Well, actually, you know, I'm going to give. It's going to give 2 stars. Okay, it's not as easy as wood. Okay, but it's going to be a little bit better than concrete. And strength. What about it?
4.
2, 4.
3.
Okay, well, strength, we're going to give it 2 stars as well. All right, and what cost? Well, concrete, about cost.
That's pretty expensive. 2.
We're going to give it 2 stars. Okay, the workability of it?
1.
3.
1. So, you guys know when they pour concrete, right? What happens if I take a bunch of concrete and I just pour it on the ground? What would happen?
It
It
waste
just-
a lot.
So what do we have to
waste
do?
a lot of concrete.
Put a little, like build a
You have to make a mold or a form. So before you even do concrete, you got to build a form out of wood. So you're actually building it out of wood, or sometimes a little bit of steel, and then you're filling it with concrete. So you're actually building the thing almost like twice. So it's hard to work with, but you can put it in some pretty neat and different shapes, because whatever you make the form of. And the strength of it.
3.
I'm going to give strength. Yeah, we're going to give that.
2.
We're going to give that 2. Okay? So every time we build something, or at least I design something, we have to figure and work with the owner, because what do you think the owner's most worried about?
Cost.
Yeah, he's worried about this. Okay? He's going to be worried about cost. So we have to go ahead and figure out, you know, what we can do. Obviously, you guys have been in some houses, and houses have big rounded curved walls and all that kind of stuff. So really workability, because people want it to look good, is going to be one of the biggest things. Okay? So that's kind of what I do day in and day out. I draw plans. I should have brought some plans in. But we tell the guys how to build it, where to put the steel, how much steel, how big does the steel need to be, or the wood, or the concrete, or how much rebar needs to be put in the concrete. So all that sort of goes into what I do every day. So basically it's like, you guys all have done Legos and stuff, right? And they give you those plans of how to put everything together. Well, basically what I have to do is I have to, you know, make those plans. Okay, tell them how, I don't build anything. I just got to tell someone else how to build it. Okay? That's what I do. But now you guys don't worry about that. We want to talk about building bridges and knocking them down. That's a lot more fun.
Yeah.
Okay? So, I'm going to give you guys a very quick, basically 4 years of engineering school in about 20 minutes. Okay, so pay attention.
1 year.
Yeah, we're gonna go pretty fast, okay? So, first thing we're gonna do is we gotta pick out a material that we're gonna use, okay? Yeah, back in. So you gotta keep doing that all the time. So my material that I'm gonna be using right now, it's a material, it's not a material that I ever use, it's a sponge, okay? Now right now, basically what we're gonna do is we're gonna create a little bit of a, sort of the bridge that we're gonna have to build. I'm gonna see if this is done here. Can I get up here, is that gonna fit the screen? I'll just move it down.
You're good.
Okay, so right here, we're gonna separate this table out. Basically, this is my bridge right now. If I take this,
We can't see the sponge.
oh, I'll pick it up in a second. Got it?
There we go.
There we go.
Oh, no, it won't stay like that.
Okay.
I'll hold it right
Okay.
Yeah, so if I push down on it, that's basically gonna be my bridge, and I'm gonna pick it up here. You can leave it be. I'll just leave it. That's right. So if I push it, okay, what's happening to the top of this sponge? Tell me.
Bending.
What is it doing? It's
It's
pushing together. Okay, we're gonna call that compression. What about the bottom of this sponge? What is it doing? If I pull on it, what's gonna happen? Yeah, it's gonna start ripping it apart. Okay, we're gonna call that tension. Okay, so the two things we're gonna talk about is compression and tension. So, if I have my sponge, and I'm gonna cut it in half, we're gonna do a cross section of that sponge. Okay, so there it is, and right, if I cut it in half, that's what we're looking at. Get back in frame. Can you see that in the frame?
Yeah.
Okay, good. Okay, so the top part, if we're pushing down on it, the top part is in compression. The bottom part is in tension. Okay? Those are two terms that we're going to be talking about right now. Someone go back there and there's like a red ruler in there. Can you bring that to me?
Pass that.
That's a good one. Okay? Oh, that's a sponge.
Too squishy?
That's too squishy. Okay, so this is, imagine if, this is our member. We're going to put this thing in tension. What do I need to do? If I put my hand on this, what should I do? If I'm going to put it in tension, I'm going to pull it apart, all right? So you think, if I'm pulling, it's going to take a lot before I break this, correct? All right? So it's pretty strong. Any material is strong in tension, okay? Now, how am I going to put it in compression? What if I do this? I push on. Now, how hard do I need to push on it before it starts to bend? What do you think? Not that much. So this is very strong in tension, okay in compression. So come up here and stand up here for a second. So I want you to put your two fingers like this on either side of it. No, I'm going to hold it. So if he does that, he just braces it off. And I can push a lot harder. Okay? So as long, if it's increased now, as long, okay, if it's braced, we can get a lot of compression on it. Okay? So that's what we're going to kind of keep working on. That's just some things to think about. Okay? The last one we're going to talk about is something that's in shear. And I'm not going to draw the picture of it. But if I take my thing and I push on it like this on either hand, what would happen if I eventually, what would happen to this ruler? It would snap right in half. That's called shear. We'll talk about that in a little bit. Okay? So, if I'm looking at my sponge, okay, if everything is happening, when I bend it like this, where's most of the compression happening? Is it happening at the top, in the middle, or at the bottom? If I'm compressing like that, where? Where's all the compression happening? Right at the top, right? That's where it's happening. You can see it, that's where it crunches up. And where's all the tension happening?
The bottom.
Right at the bottom. So if I was going to add more spongy material, where would I add it to this sponge? And where else?
The bottom.
And the top. Okay, the bottom and the top. So if I was going to add more sponge material, I would add it here, and here, and down here, and here. Okay? Does that make sense? That's where we want to add our extra material. Okay? When we guys are building our bridges, more material means more money. Okay? More material, but more money. But you're going to get the most bang for your buck if you put more material here at the bottom and at the top. Now, you guys have seen I-beams, or they call them I-beams or something like that. Why? Why do you